Hello and welcome to Paanduv applications. Today we are going to run a default case for macroscale and microstructure modules using PravaH. This icon on the screen is the logo of PravaH, the world's first all-inclusive 3D computational software developed by the R&D team of Paanduv. On clicking the logo, we will be directed to the terminal that dynamically shows all the activities done by the user on the GUI. Here we are. This window before us is the intuitive, minimalistic, and additive manufacturing process dedicated GUI of PravaH. Here you can check the license status, whether it's active or inactive. PravaH comes with three modules that are Macroscale, Microstructure, and AI, which is the deep learning based module. Users can navigate through different modules by clicking on respective tabs. Here on this side, you will find the input section for creating a new project. You enter your project name here and then click on create new. Or if there is another existing project you want to continue further, you can simply click on load project. I'll be naming my project and then click on create new and save it in my systems directory. Now I'll click on this Macroscale module, which is used for examination of melt pool analysis for the laser powder bed fusion process of additive manufacturing. Here you can see these tabs. On the left, take inputs for the thermophysical properties of different materials, process parameters, and simulation conditions. Below this, you'll find the buttons to execute your simulations such as Save All, Run Solver, Resume, Launch Console, Show Powder Spreading, Show Results, Save and Terminate. And here you can find the Help button in case you get stuck in the process. Now firstly, I'll click on this Material tab button and it will open a window for us to input material properties, which includes solid alloy properties, metal vapor properties, molten alloy properties, and shielding gas properties. On the left, you can select the material, that is an alloy which you want to work on by dragging down this arrow. You can also create a new alloy for your new research purposes. Up next, we have the shielding gas. You can select your respective shielding gas. Default properties for argon and air are provided. Users can customize these properties and save the changes. And now we select if you want to keep the vaporization on or off. So I am working on the default case, but you can put your preferred parameters and then click on the Save button to apply the changes. You can also reset the entered parameters to revert to default properties. Now I'll check on the terminal if my values are saved. So this message shows that the values are saved. Our next step is to input the process parameters. Here you need to upload this scanning pattern and powder size distribution and your preferred laser properties such as laser beam components, laser power, Fresnel coefficient, and spreader properties and initial chamber conditions. You can also visualize your scan pattern and you can also check your scan speed. I'll save it and then check on terminal. The values are saved. Now next step is the computational settings by clicking on the simulation button, which brings us to this window that includes these sliders that are accuracy, maximum current number, performance, and data saving frequency. You can also select number of CPU processors for parallel processing. The accuracy and performance sliders are available to adjust the mesh size. Users can fine-tune these settings based on their specific computational requirements and balance the trade-off between accuracy and performance. So I am selecting the accuracy 50 and save. The terminal will show this message along with the mesh size, conic number and maximum time step. Now I'll click on back, save all to see if all the values are saved. Now I'll click on run solver. On the terminal, it shows launching macroscale modeling with PravaH, pre-processing and generating mesh. Now it's showing that preparing powder bed for layer 1 using discrete element model. You can also visualize your powder spreading by clicking on this button, Show Powder Spreading. And then it will connect you to the ParaView where you can visualize your powder spreading. And this is the spreader. If you play the animation, it will show the spreader spreading the metal powder over the surface. You can also change your view. Okay. Now we'll click on Show Results and check on terminal. So the simulation is started. If I click on Launch Console, you can also check your residuals, and on the terminal you can see elapsed process time, remaining process time, estimated remaining clock time, used storage. The terminal shows that my simulation is completed 0.037%. So this process can take some time depending on your process parameters and the computational resources you are using. Now if I'll click again on Launch Console and check on terminal, it will show that the estimated remaining clock time is 12 hours and the simulation is completed 1.1%. Now as our simulation is completed 100%, we'll click on Show Results. And then on ParaView, we can observe this melt pool creation as the laser is directed onto the metal powder. You can also change your views. And you can clearly observe the solidification occurs on cooling. Now to visualize the melt pool depth from the middle section, I'll cut the solid and then I'll click on clip and invert and then apply the changes. So here you can have a clear view how the melt pool is created.